So we have 4 speakers. This is the first of 2 flash sessions, the best sessions of the day. And I want to test this morning's hypothesis that we cannot multitask. So whoever can tweet in proper English every single flash session, back to back, 4 today and then 5 this afternoon, gets a prize. I'll figure something out. But I just want to see, I think this is good to get a quick snapshot insight into what these companies and representatives of their companies are doing. It's a Future Lab session. It's forward-looking, new things that they're working on. The first one is Sam Herbert from 67 Bricks, a company that I did not know about. Is working on content enrichment. I look forward to hearing your first flash session.
Thanks, Sam. Hi, I'm Sam Herbert. I'm the Client Services Director at 67 Bricks. What we do is we help publishers and information providers implement content enrichment tools. For example, integrating Temis Luxord and MarkLogic. What I'm going to do is look at a specific science article abstract. We're going to see what semantic information can we add to it, and what are the benefits to the content consumer of doing so. I'm going too fast. So this is a fairly typical science article abstract, and what we're going to do is run some enrichment processes over it and show you the kind of information we can get out of it, and talk a little bit about what the benefits are to the consumer of doing so. So first of all, keywords. We're identifying keywords through a grammatical and statistical approach. So grammatical looks at the position of the term within the sentence structure, and statistical looks at the frequency of terms against the corpus, in this case, Wikipedia. What we can use that for is to build a basic fingerprint of that article. Once we've done that for all of the different articles in the corpus, then we can build a relatedness algorithm that compares articles and displays related articles. Next, we're going to move on to we've looked at entities. So this is identifying terms within a known taxonomy. Here, genes and proteins. And once we've done that, we typically have an ID. Once we have that ID, we can go out to the internet and get other useful information like alternative names. We can implement things like semantic search using this capability. So the user may be searching for GP2, that isn't specifically referenced here, but because we know it's the same as envelope glycoprotein, we can surface that in the search result. Here we're looking at medical entities. We're using the mesh taxonomy here. Now, mesh has a hierarchical structure, and that gives us some other interesting capabilities. For example, we know this is about vertebrate viruses, even though it isn't specifically mentioned. So we can do things like taxonomic browsing or faceted search. We could provide the user with an ability to say, I'm interested in all articles that do discuss vertebrate viruses, even though that isn't specifically mentioned within the content. We can identify geographic locations. Here we are identifying things against the geonames database. That gives us some interesting information, like population, like, I don't know if this is useful, the administrative division, and the longitude and latitude. We can obviously use that kind of information to do a map visualization, plot this information on a map, or allow people to filter or facet on geographic region, because again, it's within a known taxonomy, we can do that. The next thing is looking at relationships. So here we're identifying the relationship between entities within the content. Now this is starting to get really interesting. So what we're trying to do is capture here what the researcher is trying to communicate with this article. That gives us some really powerful capabilities, like we could allow a researcher to find all articles where envelope glycoprotein is interacting with the Ebola virus, potentially a really time-saving search capability there. Here we're moving away from looking at the individual terms themselves and looking at all of the terms and thinking about what is this content about. And this is called classification, and this is that there's a machine learning approach that we've used to do this, where we train a statistical model based on a set of training documents. And once we have this in place, we can start to feed specific content or specific articles to specific users, deliver a real niche subset of content to a specific audience. We can pull all of these different things together to create what we call an article semantic fingerprint. Here we've got the geographic location, the keywords, the classification, and that gives us a really powerful tool to utilize. For example, we can improve relatedness through this. Once all of our articles have had the semantic fingerprint applied to it, then we can compare articles and give really relevant related results to users. But we can build on this. We can use these semantic fingerprints and build what we call a user semantic fingerprint. So as your user goes around your site, we can inherit some of the semantic characteristics of the articles and build a user semantic fingerprint. And that gives us some really interesting personalization capabilities. For example, personalized notifications. As a new article comes in, we apply a semantic fingerprint to it, we compare it to the user semantic fingerprint, and then we can fire it off to the user and say, we think this is really relevant to you. So my final thought is that semantic content enrichment is becoming a core competency for publishers and information providers. We think it's a powerful tool for you to help you meet your customers, your content consumers' needs and expectations. So it's been fairly quick. I'd be happy to have any questions later on.
Thank you, Sam.